Hey everyone, Ben from JangaFX here. Today we're going to be detonating a nuclear bomb, finally. And in particular we're going to be looking at something around the range of 20 to 50 kilotons. So not the biggest nuclear explosion you've ever seen. Let's not go crazy, let's start small. I'd love to revisit this subject in a later tutorial, make something massive. But to make this happen, we're going to be using a couple of particle emitters and a couple of different forces in concert with each other to help art direct our mushroom cloud. And also we are depicting something here at a really large scale. So we're going to want to play with the speed of movement of our smoke to really fake that larger scale. Okay, first things first. Let's set up our bounds. I'm going to go for 512 all the way around. And if we need it, I might make it slightly larger. I'm also going to go with 0.5 meters for our voxel size. So that's going to drastically change how this particular default fire looks, but it's going to work for what we're building. So let's get rid of all of these guys. We're going to bring in a particle emitter. And to feed that particle emitter, we're going to bring in a primitive shape. It's going to be a sphere. We're going to make it, let's say 5. We're going to bring it up off the ground to maybe 15. So the particles it emits are going to be very, very short-lived, and they're all going to show up as a burst on the first frame. So we're going to turn off continuous. We're going to turn on burst. Let's leave that at default for now. So we need to go to initial forces. Where it says velocity none, it means they've got no speed. We want them to come out with loads of speed. So let's go velocity from position. That means every point along the surface that these particles are born, they're going to come outwards in that direction. So a sphere for this is perfect. So they're going to come outwards in a big sphere. We're going to bring these speed limits all the way up because we want them all to come out at a very, very similar speed. Speed scale, let's whack that up to 10. And so that we can see what's going on, we're going to bring in some smoke injection. And we're just going to try that. It's not a bad start. In fact, right from the off, there's already a kind of mushroomy shape going on. But we can vastly improve on that. So let's go back to our initial forces and play around this a little bit more. So we've got, these guys are all good. I kind of want loads of velocity, but also want that velocity to die out really quickly. See if we can get like a really rapid expansion. Bring fuels up to, let's just see what 100 looks like. That's not too bad, but I would say there's not going to be quite that much fire in a nuclear bomb's explosion. So we would want the fire to die out very, very quickly as well. Let's see how this looks. Very quickly replaced by smoke. That's cool. Let's bring down the amount of smoke to say, let's just try 25. Let's bring our temperature way up because this is really, really hot when it explodes. And let's also bring in our other particle emitter, which is going to represent the ground. And we're going to give that a shape to drive it as well. It's going to be another primitive. We're going to choose an ellipsoid and we're going to make it as wide and as long as we can, a bit bigger actually, let's say 150, 150, and that forms like a disc of ground. It doesn't need to be quite that tall, but that doesn't matter too much. So this is going to birth loads and loads of particles right at the beginning. So another burst emission. We want as many as we can possibly get because this is the ground. Let's just see what that looks like real quick. Make sure rendering is on so we can see them. Let's make this a little bit smaller actually. So 125, 125. Let's try that. It's pretty good. Turn this guy off just for a moment. Let's make sure they're frozen. So emit frozen, pause until unfreeze. We're going to bring this right down to say like 0.3, 0.3, so that when we've got stuff happening in the scene, they are going to get woken up. And we're going to bring up the size of them as well, just so we can see them. There we go. Cool, right. So we should get a little bit of movement coming from this explosion. So it should wake some up. There we go, look. It's not perfect, but it's a start. So I think we can probably bring down the life of these guys to maybe 0.1 or something. Once they're born and they've woken up, they've emitted smoke. They don't need to then carry on emitting smoke. You know, they've done their job. All right, cool. So I've tinkered with a few settings here, and we've we appear to have hit a good balance between, you know, the energy coming off of our bomb, waking up the particles on the ground. It's a little bit too extreme, but we're going to dial that down. In fact, I believe what's happening here is the noise over here is suddenly acting on everything that's woken up. So if we were to turn this off and then rerun from the beginning, we will still get these particles waking up and giving off smoke, but they won't be moving around quite so much. So let's try and hit a middle ground there. Let's turn it back on, but let's scale it down and also bring down that animation speed to maybe, let's just try 0.1, but the scale down to 0.2. And let's bring up the octaves a bit as well. And also the amplitude, let's bring that down to say 0.3. Okay, it's a cool start. Now we need some force to come out of this, because currently the only force is, you know, what's coming out of this particle emitter bomb. Let's bring in a force and make it a point force. And we're going to make sure that this point force is in the exact same spot as our bomb, and that's at Z15. So let's bring that up. So the central point of all the force that's coming out of this is going to be exactly the same as where our particle emitter bomb is. And we're going to add in, let's say 100 here. This is going to look pretty crazy right from the off. It's just going to blow everything to smithereens. So we need some fall off. So let's go with, say, 15 maybe. And we don't want this running all the way through the animation. We're going to sort of flash it on and then dial down the settings over a few frames. So it's going to be on to begin with. That's cool. We want our pressure rate here to be animated. So add a keyframe. I'm going to bring it up to 100, and then by frame 80, we're going to bring it down to 0. And we're just going to see what that looks like. I might bring up the fall off radius to say maybe 35. Let's see what that looks like. Very cool, but way too big. Let's try 25. Now we're obviously going to cut the top of this explosion off. So let's look at the other thing that we want to do, and that is to, you know, bring down the speed of things over time. And we go to my old standby, which is dissipation of velocity. Let's try 80 and just see how that goes. Pretty cool. Now we've got way too much fire in the top of this mushroom cloud. It would burn very, very quickly and then be gone fairly quickly as well. So let's look at that. Let's go to our combustion, advanced parameters, and then fuel loss. We want to bring that up to say, let's see what 90 looks like. So any fuel there is, it burns through pretty quick. Here's me remembering that these aren't fuel-based flames. These are flames that are injected directly from the particles. So let's have a look at that. That's over here. There we go. So let's bring this down to 20 or so. And in fact, maybe the lifetime of these particles. Yeah, let's go with that and that. Okay, that's a little more like it. It's very, very uniform down the bottom, so we're going to break that up a little. And then we're also going to work some noise into this to break it up quite a bit. I'm quite enjoying that automatically there's this sucking in effect. So there's an outward force, and then as the fireball rises, it pulls the smoke in under it. Now, what can we do to randomize this up a bit? Let's look at our ground. I'm going to bring this over here, and we're going to look at the shapes. Let's change the size limits. So we've got some larger and some smaller. Let's change how they're distributed on that ground plane as well. So let's go with entangled. I just want it to be slightly less uniform. Let's also look at the life. Still quite smooth. So let's bring in some vorticity. So let's go with, take about 25, bring in large vorticity at 15. Let's see if that breaks it up any. That's a bit more like it. equally, there is a huge amount of temperature in here, and that is forcing everything to act under buoyancy and go up very, very quickly. So we're going to have to change a couple of these effects as well. That's also our point force. We're going to bring that down so it happens quite quickly. Let's play with our buoyancy. So we go to our simulation and go to our forces. And let's just bring buoyancy down to, say, 50. So these things are still as hot as they were before. It's just they are less likely to go up as quickly as they were before. And this is cool. I like this. I believe that we would still be losing the fire a bit quicker, but we can totally work with this. So I'm going to turn off our skybox. This is cool. Right, so I can already feel that it's slowing down as it goes up. And one thing I want to do with this is for it to explode, give us a mushroom cloud, and I really want it to just hang ominously in the air. So let's really crank that up. Let's go to Dissipation, and we're going to bring our velocity dissipation to 99.999. This is obviously way too high, so we're going to bring this down. Let's try 90. Maybe we can bring that velocity dissipation right up once it's got to a point where we like it. So we'll let that mushroom cloud form. In fact, yeah, let's do that. So bring it to its default. We're going to animate. So I'm going to set a keyframe for 0. Let's let it run. And then maybe by the time we get to here, we want this thing to be absolutely crawling along. So bring that up to maybe not 100, but 99. So between these 2 points, it should gradually slow down. And we might have to play around with this after the fact, but let's just see how it looks. Cool. Right. So let's also bring down the size of this to maybe 75 by 75. Just want to see if that makes much difference, because it all still gets pushed outwards. We get that rolling wave there. It all gets sucked back in. What we can do to decrease these edges, they're quite visible. Let's go to volume processing, bring in our slicing mask, and we want to use the X, Y, positive and negative. So let's go for a width of 20. Tab, tab, 20, tab, tab, 20. Tab, tab, 20, and that should break that up a little bit. It should be less obvious where the edges of the domain are. It does slow down pretty quickly, so let's bring our velocity dissipation along, maybe to here. See how that looks. It's all very uniform as well, so we might try and break this up a little bit. So we'll bring in a couple of different layers of noise. In our simulation node, under Combustion, Extinction smoke gain is set at 15. So this is smoke that's generated by a fire that's burning. So if we were to crank this up, every time flames die, you know, smoke gets born. Let's see what that looks like then. Might be quite thick as it goes up then. Because I noticed that the smoke is really thick down here. Okay, that's pretty cool. Love that shockwave coming out. That's cool, we got a good shape. So we've got the basic anatomy of this right. We're going to use a couple of different forces now. We might play around with this point force just to give it a bit more boom a little bit later. We're going to use 2 line forces together. One is going to push this up slightly faster at the beginning, and we're going to use another opposing line force at the top that is going to push gently down, and it's also going to spread this mushroom cloud out to make it a little bit wider. Portobello mushroom. So let's bring those guys in. So you may not notice about the line force, but you think of just a straight line and it's always going to push in that direction, but you can actually You can give it fall off outwards, but you can also stop it from going all the way along that line. So currently this force travels all the way along here. If we were to use a line segment, so if we turn off fall off, use a line segment, and it would only be active along here. After this point, it would kind of stop. So if we bring our fall off radius out a bit, because we want to capture a bit more of the ground stuff and send it upwards. Yeah, it's definitely pushing stuff. That was actually kind of cool. Totally not realistic. Let's just find a good value that works. So, obviously this thing was already headed upwards because it has that heat, it has that buoyancy. I wanted to give it a little bit more urgency because that can actually be quite a big factor in how the mushroom cloud is shaped, because you're sending through this column upwards. Let's also bring that velocity dissipation back a bit because I really like the movement of it. And we're going to have a second opposing force pushing down, and that's going to be like we're going to pretend that that's a lot of really high altitude cold air that's sort of pushing back on this mushroom cloud. We'll keep it there, but we didn't really need it as much as I thought because we've got good upward motion there already. I think that's down to the temperature. But let's bring another one in to oppose that upward movement, to push it back down and to kind of push it outwards a little. So let's bring down another force, another line force. This guy's going to be called down. We're going to use fall off again. We're going to make sure it goes out, kind of to the length, the width rather of the sim. We'll do it, and we're going to push in -1. But we're also going to bring it all the way up here. Let's bring this right down to 0.01. I'm not sure if that line segment length actually works or how it works. But let's just make it something quite small. I'm not sure if the visual indicator here actually reflects the length of that. But let's bring it roughly up to this point here and we'll see if it pushes down on that smoke. Because we don't want it to push down on the smoke here. We want to wait for it to get up to the top. There, that's being shaped. So it's being pushed down. So what if we bring this down a little bit further? That's cool. It's bringing quite a lot of turbulence into it as well, which I'm quite liking. So let's we also want some repel strength outwards. So let's plug in like 10 or something and see how quickly it pushes it out to the outside of the domain. So as it comes up, it should also go outwards. That's kind of cool. Let's bring it down and bring down the speed of that because we don't want it to speed up. We just kind of want to gently guide which way it's going to go. Let's change that push strength to -1 again. I wonder if simulation, dissipation, temperature dissipation. Let's bring this up to 90 and see how quickly the buoyancy drops off. That was pretty cool. So that solves our fire burning out quickly issue. It's pretty good, but we've also got, it's almost like there's too much movement here. So let's get rid of this guy. And maybe we'll roll this back just a little. I kind of like what it's done to it. Okay, so temperature dissipation to what, 50? Let's try that. And also we can drag this up to here as well. So we can make the slowdown of our velocity dissipation happen sooner and try and catch it before it gets to the top of that box. I just want to bring a tiny bit of movement back in because we've all but stopped here and we want it to be hanging in the air really ominously, but we still want it to have a little bit of flow about it. So let's just check what 99 looks like. I love that rolling under, that's quite cool. So as we get there, we can maybe bring this back here and try 95. That's pretty cool. So I really like the idea of this monumental mushroom cloud being so big that, you know, there aren't really any winds or phenomena that can really push it around that much. Obviously they would in the real world, but we just want something that looks big and unmovable. Now we've got some vorticity breaking that up at the moment, so maybe we can roll that back a little. Let's just try 5 and 10. All right, I've tinkered and made just a couple of changes. Namely, our ground particle emitter, I've added some flames on activation so that we get like a front of flames coming through here. What else have I done? I've disabled these guys because they weren't doing as much as I wanted them to do, and I'm quite pleased with the motion that we've got, given that we've got our velocity dissipation kicking in, and it kind of locks our shape in at a certain point. Bearing in mind, you know, any changes that I do make from this point out, I'm going to have to go back over this velocity dissipation just to make sure it locks us in at just the right point. We've also got some smoke dissipation going on here, which I'm not happy about. Let's go over to there. Yeah, we're getting rid of smoke. We don't want that to go. We want that to stick around. Let's see what that looks like on 0. That's a bit better. I've added some weight to the smoke under the simulation node and looking at the force tab, so that any lingering smoke down here just kind of falls down a little. In fact, that's happening up here, so I'm gonna turn that back a bit. Let's use maybe 100. It will still happen, but you know, much slower. That's pretty good. I like that. So let's just whack a bit of noise in there, and then we can pretty much call this done. It's obviously up to you how you would use this effect, whether you're exporting VDBs to use in another application, or if you're exporting this as 2D images to use in a comp. But if you're doing that, you might want to add a light at the beginning, which we'll do. We'll add a really strong light through here that shines through all this smoke. In a real world nuke, that would happen really quickly and be really quite brief. So let's bring that in here, point light. And that's going to be at 15. That's as high as our point of explosion. Let's bring that all the way up and just see what it looks like. Something a bit like that, and then it would just suddenly stop because everything would be used up, and it would just be left with all this fissile material burning and then the smoke rising. So let's animate the intensity from 5555 down to 0 at about here, I reckon. So bring that down. Back to the beginning, we'll have it all the way up. In fact, what we'll do, we'll go all the way down. We will go from the very beginning here. So right at the beginning we're off. A couple of frames later, the light comes on, got a blast wave, and it subsides. That's pretty cool, like that. Okay, a bit more noise. So we're gonna copy, paste. We'll grab a couple of these. And what we're going to do is we're going to have them operate at slightly different sizes. So this one is at 2. Let's bring one in at 1. And another one in at, say, 4 or something. And just see if that breaks up these shapes just a little. It's pretty low strength. So all combined, these 3 should work pretty well. I would maybe even bring our vorticity back in, say 20. That's cool. I like that. Another thing I was thinking of was maybe let's use our ground particle emitter with another shape. Let's do an import. Okay, here we go. Here's a rough city model that I've downloaded from SketchFab. I'll make sure I put a link up to the original artist down the bottom. And I have sort of reduced the geometry a little bit, and I've exported it as an FBX, brought it over into our import node, and we can use that as a particle emitter. And we're just going to use this as an extension of the ground, really. So we've still got the ground plane underneath, but we're also using the geometry here to birth some particles that are going to get moved around by our explosion. It's kind of similar to what we did with the barn in the Twister tutorial. So we have a bunch of smoke and fire that's then emitted from these buildings, and you'll see in a second it gets sucked back in under. Now the problem here is we've got buildings that are birthing these particles, but in a real nuclear explosion, those buildings probably wouldn't be standing now. They'd be long gone. So if you were to try and make this happen, you'd have to animate the imported geometry on and off. Maybe you would get to the point where the particles are all born, i.e. around about here, and then turn off that import node and let the rest happen. And then you'd have to get a bit creative about how you're going to composite these things. That's certainly something you could do. And you might be saying, Ben, if you're using some imported geometry, why not use it as a collider? Well, you can. There's a lot going on in here, so EmberGen's really got to think about where it's going to push all these forces and what it's going to bounce off of. But the solver can handle it. It takes a few frames to really get up to speed. But again, the problem is this wouldn't be a collider for very long in real life. These buildings would be gone pretty quickly. And as such, it really does affect the shape of our explosion. So creative decisions-wise, you'd probably not want to use that. But the option is there if you want it. I do quite like the look of all these particles that come off though. Alright, I'm really pleased with how this one came out. Slightly different to how I'd planned because I was going to use a little more extensively these up and down forces. But it turned out that the motion that I ended up with I was quite happy with anyway. When I used the heat and buoyancy to push this thing up, and then I used that in conjunction with the velocity dissipation to slow it down as it gets to the top. I feel like I kind of learned a new way to do it this time around. But you may find that creating these line forces when you have a go could really help out. So just to take you through how we built this again, we have two particle emitters. One is for our ground plane, one is for our bomb itself. Our bomb shoots out a load of particles at high speed, which have a lot of temperature and a lot of smoke to them, which then start to go upwards. And our ground plane has a load of frozen particles on it that only emit smoke. I think I dropped all of the temperature out of those guys as well. So they also have some flames, so that if we can go back to the beginning, as this ring expands, you'll see that there is some fire in there. So we've got some fire and smoke and some outward motion. So this billowing out is because of our velocity, which is dropping off over time. And also we have got some shredding enabled in our simulation node. So those two things are making this thing expand outwards. We've also got a point force here as well, which is just pushing things out a bit more than they would have. It's kind of helping the particle emitter bomb. We've got a few different noises in here, which are just putting some of this detail in. And they're quite weak because there's three of them. If you have three of these all at high amplitudes, then you'll end up with a really horrible fuzzy mess. But if you use them quite subtly, it will look quite nice. I've also told our smoke to not dissipate because I want this to be a massive dirty explosion. I want there to be loads and loads of smoke. And it's quite structured as well. It's not just smoke everywhere, it's smoke in specific places. So we don't want that to just dissipate after we spent all this time trying to direct it where we want it to go. And that really is it in a nutshell. It's all about buoyancy, timing, and of course these two particle emitters. So we're going to leave it there. If you have any questions about how to do this, you are very, very welcome to find me on Discord, or any member of the team really. I'm sure they can help. You're also welcome to reach out to me directly on Twitter, where I'll be glad to help. As usual, you can find this very project file, linked as a download in the description of this video, and I will catch you the next time. See you in the next video.